Hello guys, welcome to my someone maths tutorials. In this video we're going to talk about the boundary value problem, because from the last video we talked about the initial value problem. So if you didn't see that video for the initial value problem, you can check from the description below. There is a link for the initial value problem. So guys, now what is the difference between the initial value problem and the boundary value problem? The only difference is that, remember from the initial value problem, the points we had let's say y into something, and the second point it was y to the first prime or y derivative, right? So in the boundary value problem, we don't have the derivatives or the first prime. We're only given the y values the way they are, right? So it means we don't derive in what? In the boundary value problem, but then in the initial value problem, that's where we're going to derive, right? So the first example, it says solve the boundary value problem if possible. In most of the case in the boundary value problems, you'll find out it's very difficult to find the answers, right? So don't be scared or thought maybe you are wrong whenever you see like you can't get an answer. There is a possible that you don't find answers in the boundary value problem. So now let's do the example. Remember also from the boundary value problem, like I said, the only difference is that here we're not going to derive, so we're just going to plug all those values, right? So we're going to follow all the steps of finding what? The complementary function. If you don't know how to find the complementary function, there is also a link in the description below whereby we explain everything about how to find the complementary function, right? So we can now start. The question says solve the boundary value problem given y to the second prime plus 4y is equals to 0, and then we have the two values, and we can see that we don't have what? The derivative in those 2 points, or those 2 points were given, right? So you can also tell that it's a boundary value problem, and this one is easy because you don't have to derive. So the first thing that we're going to find is what? Is to write down the homogeneous equation. So writing the homogeneous equation, we're going to have the second prime plus 4y, which is equals to 0, right? After writing the homogeneous equation, as we are done with this step, now we come to the step of doing what? Of writing the auxiliary equation. So our auxiliary equation here, it can be d squared plus 4 is equals to 0. Like I said, from here, one can use m squared plus 4. It is still the same thing, guys. So if you used b squared plus 4, it is still the same thing. The aim is to get those answers. So now we are solving for d. We're going to have d squared is equals to negative 4. Therefore, our d is going to be equals to the square root of negative 4. And we know that the square root of the negative 4, it's what? It's 2i. It's plus or minus 2i. In simpler terms, our d is going to be 0 plus or minus 2i. So even though you get confused here, the video that is going to help you is the video for how to find the complementary function. There is a link in the description below. Go to check it out. So now we can see that our alpha is equals to 0 and our beta is equals to 2, right? So now we know that because we are going to use what? Case 3, because we can see that um we have what? The complementary roots, right? So the case 3 says we're going to have e into alpha multiplied by x c1 cosine of x cosine of beta x plus c2 sine of beta x. This is what we are going to have, right? So now we're going to replace the beta and also the alpha with the values that we have from E. Our alpha at 0, we're going to have 0 multiplied by x into C1 cosine of what is beta. Our beta is 2x plus C2 sine of beta, sine of 2x, right? So we can see like anything to the exponent of 0, it's 1. So the answer is going to be C1 cosine of 2x plus C2 sine of 2x, right? So now we are trying finding what? The complementary function, right? Which is the YC. So after finding the complementary function, we are going to find what? The question says solve the boundary value problem. Like I said, the only difference from the boundary value problem and the initial value problem is that in the boundary value problem, we don't have to derive. We don't derive, but then in the initial value problem, we are going to derive, right? So now we're going to find C1 and C2. This is question is all about like find the unknown values. So we're going to find C1 and C2. How do we find C1 and C2? So therefore we are given these values. The first point, which is y into 0 is equals to 0. So therefore we can say for y is equals to 0, right? And then where we see y, we're going to replace it with 0. Where we see x, we're going to replace it with 0. So therefore we're going to have 0 into C1 cosine of 2 multiplied by 0 plus C2 sine of 2 multiplied by 0, right? Then we're going to find our value. C1 to cosine of 0, cos 2 multiplied by 0, it's what? It's 0, right? So the cosine of 0, it gave us, it's 1, right? So we're going to have C1 here. And then the sine of 0 is going to give us 0. So meaning our C1 is equals to 0. So therefore, let me do this because of the space. So now we are going to find what? For we are done with finding C1. Therefore, for y into pi all over 12 is equals to 1. You can see that here we don't have the first prime or the derivative, so we are not going to derive. We're just going to substitute the way they are. So where we see y, we're going to replace it with 1. Where we see x, we're going to replace it with what? Pi over 12, right? So let's do that. We are going to have 1 is equals to C1 cosine of 2 multiplied by, there is a x, therefore we're going to multiply it with what? With pi all over 12 plus C2 to sine of 2 multiplied by pi all over 12, right? So but then we know that C1 is equals to 0. So therefore C1 multiplied by cosine of 2 multiplied by pi over 12, it's going to give us 0. Can you guys see it? Because the C1 here, it's what? It's 0. So then we'll be left with C2 sine of, it's going to give us 2 pi all over 12, right? So therefore the values that we are going to get now, it's going to be the sine of 2 pi all over 12. When you press your calculator, you're going to get, therefore our C2 is going to be 1 over 2, right? It's going to be 1 over 2 C2, because the sine of 2 pi all over 12 is going to give us 1 over 2, right? So now we can cross multiply, therefore we can see that our C2 is going to give us 2, right? So we now have the two values, then we can substitute them from the original complementary function. So our YC is going to give us, what is C1? It's 0 multiplied by cosine of 2x. What is C2? It's 2, therefore we're going to have 2 sine of 2x, right? So 0 multiplied by anything, it's 0. So therefore we'll be left with 2 sine of 2x. So this is the final answer. This is how we found the boundary value problem. You can see that the only difference in the boundary value problem and the initial value problem is that in the boundary value problem we don't differentiate, and in the initial value problem we are going to differentiate. So we are done with doing the boundary value problem. The next video, that's where we're going to talk about the variation of parameters. So kindly like and subscribe if you find this video helpful to you. Thank you guys. You can also do these examples here, 25 to 31. If you find one of them difficult, don't mind to leave a comment behind. I'll go to check it and help you with it. Thank you.